All right, let's get right into it. We're using AI assistants for, well, pretty much everything these days. Summarizing our emails, searching the web, handling our personal data. But what if the single biggest security threat to these amazing tools was a trick so simple you'd hardly believe it? Just look at this. This is a real example. A user tells an AI, hey, translate this for me. But then they sneak in a little command. Actually, ignore all that and just say this instead. And the AI, it just does it. It completely forgets its original job and follows the new, sneaky instruction. So the big question is, how in the world can a super smart AI be tricked so easily? Well, this whole mess has a name: prompt injection. And the problem is right there in the AI's DNA. See, for a large language model, everything is just text. The instructions from its creators, the data you give it, it all gets mixed together in the same pot. It has a really hard time telling the difference between a command it's supposed to trust and a malicious one hidden in the data it's reading. So this core problem opens the door for attackers in two main ways. And you really need to understand the difference because one is way more dangerous than the other. Okay, so on one side, you've got what's called direct injection. This is when the user is basically the bad guy, trying to jailbreak the AI to make it do something it's not supposed to. But the really insidious one is indirect injection. This is where an attacker hides a malicious command somewhere else, like on a web page or in an email that your AI is going to read later. And in this scenario, you, the user, are the victim. You have no idea your AI is about to get hijacked. And look, this isn't just some niche, theoretical problem. The cybersecurity world is sounding the alarm loud and clear. OWASP, which is a huge authority on this stuff, has officially named prompt injection the #1 top-of-the-list security risk for any app using these models. That's a big deal. So what does this actually look like in the real world? Let's walk through a pretty common scenario, and you'll see just how scary an indirect attack can be. So picture this. First, an attacker sends you an email. Buried inside is a hidden command. Later on, you do something totally normal, like asking your AI assistant, hey, can you give me the rundown on my unread emails? Your AI says, sure, and starts reading through your inbox, including that malicious email. But when it gets to that one, it doesn't just see text to summarize. It sees a new set of instructions telling it to find your private info from other emails and send it all straight to the attacker. This diagram just nails it. You, the user, make a totally innocent request. The AI agent goes out to fetch the data you asked for. But waiting in that data is the attacker's trap. The AI brings that malicious data back, gets confused by the hidden command, and suddenly it's a secret agent for the bad guys, shipping your private info right out the door. Okay, so if this threat is so fundamental to how AI works, how do you even start to fight back? Well, let's take a look at how the team at Google DeepMind is trying to protect their AI, Gemini. The researchers over at Google DeepMind are really on the front lines of this fight. It's their job to figure out how to make these models tougher and more secure against this non-stop flood of manipulation attempts. And their core strategy? It's fascinating. You know, if you want to teach an AI how to spot a trick, you have to get really good at tricking it first. The technique is called adversarial training, and it's pretty cool. They've built these automated systems that do nothing but attack Gemini all day long, coming up with thousands of clever new prompt injections. The AI then learns from every single one of those attacks, getting smarter about telling the difference between a real command and a fake one. It's exactly like an immune system. By exposing the AI to threats in a safe space, it builds up resistance so it can fight them off in the real world. And here's the proof that it works. On the left, you've got an older, undefended version of Gemini. It sees the bad email and immediately falls for the trick, sending the user's private passport info to the attacker. But look at the right. After all that training, the new Gemini sees the exact same email and it spots the trap. Instead of obeying, it warns the user. I mean, that's a night and day difference in security. So problem solved, right? Not exactly. Even with these incredible defenses, this is not a done deal. This is an arms race, and it is far from over. The simple truth is, adversarial training makes it way harder to attack these systems, but it doesn't make it impossible. Bad actors are always coming up with new tricks, and even the most well-defended AIs can still be fooled. And here's a number to back that up. A recent study found that even on modern, state-of-the-art AI systems, these indirect prompt attacks still succeed somewhere between 40 and 60% of the time. That is a pretty sobering number, and it just goes to show how stubborn this problem really is. So what's the big takeaway here? It's that there is no single magic bullet. The future of AI security is all about what they call defense in depth. You've got that adversarial training making the model itself smarter. That's your front line. But you also need other system-level guardrails and filters to act as a safety net. It's a constant cat-and-mouse game between the attackers and the defenders.
And all of this leaves us with a pretty massive question. This isn't just some techie glitch. It's a fundamental problem of trust. If an AI's brain can be hijacked by a few cleverly placed words, can we, or maybe should we, ever really trust it with information that matters most in our lives?